Hi everyone. So today's lesson is more on compositions. So if you're following along in your textbook, this is section 2.5. We're going to spend a little bit of time going over just briefly what you did yesterday, or what you should have done yesterday, and then do some practice problems together. Make sure that if you have any questions at the end of the video, you put them into the question document so that your teacher can get them answered as soon as possible. All right, here we go. So yesterday we learned how to do compositions of functions using different approaches. Okay, so we did numerical, we did graphical. Those were the two main ways. We also talked about algebraic. So we're going to review this numerical or tabular way of looking at compositions. So you'll notice there are these two functions, f and g, and we're going to answer the compositions that are on the right-hand side. Okay, so if I want f of g of 0, I first go to g of 0, which is 5. And so what I'm trying to do now is evaluate f of 5. So g of 0 is equal to 5, so now I want f of 5, and f of 5 turns out to be 9. Okay, I'm going to go through these, but I would recommend that you actually pause the video every so often so that you can try the problems on your own before you see the work that I'm doing. All right, inside part first, f of -1 is equal to -3. So now I want g of -3. G of -3 happens to be 8. So now we're doing a function within itself. So we're just repeating the f function twice. So f of 2 is equal to 3. So f of 2 is 3. So now I want f of 3. F of 3 is 5. And finally, g of -1 is equal to 6. So now I want g of 6, which happens to equal 1. Okay, so that is a review of the numerical approach, which could also be considered the tabular approach. Now we're going to go on to the new part. So we are learning how to actually decompose a function into its kind of little mini parts so that I can graph it, or you can graph the function without using your calculator. And even more so than just without using your calculator, it's also really helpful to be able to look at a function and be able to anticipate what the graph looks like, so that if you graph it wrong, if you type it in wrong, you'll know that the graph is wrong. And it's also important to have an understanding of what a function looks like without actually graphing it. Okay, so we're going to decompose it by doing this in steps. And at the end, then we'll write down what the domain is. I'm going to go through at least 2 of these with you, maybe 3 solidly, where I'm going to show you how to do them. And then we'll have you try one kind of on your own. And then there'll be some more practice that we'll do. Okay, so when I decompose this, I'm going to start with that absolute value of x minus 2. So here we are. It's going to be my step 1. So I'm just going to graph that. And I'm not going to do all the plotting of the points. I'm just going to graph it right there. So I know that the absolute value of x minus 2 would be the whole absolute value graph shifted down 2. Okay, so there is my graph. And I'm just going to use the line tool because I can. Okay, so there is my absolute value of x minus 2. Now what I'm going to do is I am going to reciprocate that absolute value of x minus 2. That means I'm going to take every y value off of the first graph and flip it. Okay, so I actually would tell you to start with any y values that are 0, because if a y value is 0, that means you would have an asymptote, a vertical asymptote. So over on this blue graph, there's at 2 and -2, your y values are 0. So over here on this graph, I am going to put some vertical asymptotes in. Okay, then I'm going to pick some other points that will be easier for me to work with. So I'm going to start with this 0, -2 point right here. When I reciprocate that, 0, -2 becomes 0, -1/2. Okay, so 0, negative, I'm going to call it 0.5 so it's easier to read. And then if I take a couple other points, so I've got this point 1, negative 1. Well, 1, negative 1 is still at 1, negative 1. And negative 1, negative 1 over here is still at negative 1, negative 1. So I have these 3 points. I can tell then what's happening is within this region, kind of from here to here, all of my values are negative, and when I reciprocate them, they still stay negative and they don't cross over the x-axis. So I have kind of this parabolic shape happening in the middle there. Then on the other side, so kind of in this region on this left graph, anything that I reciprocate over here, it starts off positive and stays positive. So for instance, I have the point 3, 1. Well, 3, 1, reciprocal of 1, so 3, 1. The reciprocal of 1 is still 1. So I still have the point 3, 1 over there. But then I have this point 4, 2 on the blue graph. And the reciprocal of 4, 2 is 4, comma, a half. So if you kind of get the idea of what's happening here, this part is going to be turning into this, kind of looks like 1 over x graph in that space. And actually, you're going to have some symmetry because the graph looks the same on the left side on the blue graph. So over here, this is the same. So then it's going to take on the same shape in the green. So there we are. Not done yet, but I'm pretty close to done. So I'm going to label a couple more of these points. So this is now negative 3, positive 1. This was that 0, negative a half. This is 1, negative 1. And then the third step in the problem here is now to shift the whole thing down 1. So the graph to the left is now going to go down 1. So this 0, negative a half is going to go down to 0, negative 3 halves. And I still have verticals at 2 and negative 2. And I now have the point 1, negative 2. And negative 1, negative 2. And then the point 3, 1 goes to 3, 0. That we kind of had a horizontal asymptote, I guess you could say, at 0 originally. So now there's one at negative 1. And so now here's the new graph. Yes, you will be expected to do this without a calculator. So you'll want to practice this. And you might want to be able to explain your steps as well. So knowing that the first thing we did was graph the absolute value of x minus 2, then we reciprocated the y values. So I'm going to write that again, reciprocate y values. And then we shifted, okay? When you look at this blue graph, you can see the domain is from negative infinity to negative 2, from negative 2 to 2, and from 2 to infinity. Okay, if you need to pause it now so you can copy everything down, but I'm going on to number 2. So number 2 is a square root function. So in the final result's going to be a square root function, but we're actually going to pick it apart into 3 pieces as well and start with just the absolute value of x minus 2. So this is actually a horizontal shift. So this is going to go, your absolute value graph is going to go to the right 2. So normally at 0, 0, now we're at 2, 0. We got some points like this. Got 0, positive 2 in there. I'm going to go ahead and graph this with the straight edge as opposed to me with my pen. So there is our shifted to the right absolute value. Oh, it looks like this didn't cut and paste properly. I apologize. So this should have the +1 in this step here. That seems to have disappeared. Sorry about that. So write that better. So now we're going to just take our absolute value graph and just shift it up 1. So what was originally at 2, 0 is now at 2, 1. What was originally at 3, 1 is at 3, 2. And so I'm going to just graph a few more. I like to graph any intercepts if I can. So I knew there was a y-intercept, so I wanted to graph that. Okay, so then here's where people tend to get a little confused and worried because they're confused on what their next thing is they're supposed to do. Okay, so basically what you're doing to go from step 2 to step 3 is you are taking the square root of the y values in step 2. Okay, so for step 3, you are taking the square root of the y values in step number 2. Okay, so for instance, I have this point. Let me get a different color. I have this point 2, 1 on this black graph here. I'm taking the square root of 1, and the square root of 1 is still 1. Now I have this point here, 3, 2. I don't know that that's very helpful for me to take the square root and graph it. So I'm going to go to where I know there's a perfect square. So I'm going to go all the way over to the point 5, 4. So I have the point 5, 4 right here. And I'm going to take the square root of 4, and I'm going to now graph the point 5, 2. So I have 2, 1, and I have 5, 2. And over here I have the point -1, 4. So that means I'm going to have the point -1, 2. Okay. The tricky part to drawing this is knowing that kind of the final outcome. If you have some small numbers in here that you're taking the square root of, they don't actually get small as fast as the ones on the ends. This graph actually takes on, it kind of reminds me of one of those birds maybe you used to draw when you were a kid, right, on your papers. So it kind of has that bird-like shape. Okay, again, pause and finish the graph if you need to. Write down any questions you might have as you're going through so that you can ask them on that document. Oh, sorry, we forgot to talk about the domain. So when we look at the domain, you're looking to see what x values won't work. Well, the good news is on this problem is that they should all work because you're taking the absolute value inside there, which means everything becomes positive. So this domain is all reals, or you can, of course, write it as -infinity to infinity. You could actually write out the words all reals if you wanted. I'm just being lazy. All right, number 3. So, this didn't copy the way I wanted it to either. So let's do this. Okay. So 1 over 1 minus x squared, we're going to start off by graphing -x squared. That's just your quadratic function flipped upside down. So I've got those 3 defining points, and I'm going to add one more in there. Okay. So this is your typical parabola flipped upside down. So -x squared. Step 2 is telling you to take all of the points and shift them up 1. It's the same as if we wrote it as -x squared plus 1. So now we're going up 1. So we're at 0, 1, 1, 0, -1, 0, and at 2, -3, -2, -3. And as we're drawing these graphs or plotting these points, don't forget you're always welcome to shove some numbers in there to make sure they work. Okay, and then this part is we're going to do that reciprocal part, that reciprocate. Okay, so you are going to take the reciprocals of all of the y values in the red graph. So I'm going to start with actually any place where the y's are 0, because if the y's are 0, we're literally saying 0 equals 1 over 1 minus x squared, which never happens. So wherever it equals 0, you are going to have a vertical asymptote. So that is at -1 and +1. And then I'm going to take the other points on the graph and start reciprocating them, keeping in mind that anything that is positive, so in this region, anything that is positive will stay positive. So the reciprocal of y equals 1 is 1, so that point stays there. And then let's say you have like a half or a third or whatever. Anything that's a fraction in this little region in here, I'm pointing with the stylus, you can't see. Anything in here in the x's has y's that are fractions. So when you reciprocate that value, it becomes bigger than 1. So what ends up happening is you are getting a little, kind of looks like a parabola in that region. That's not what it is, but it kind of looks like that. Okay, and then the same thing is happening in these regions over here. So basically, any value that is between 0 and -1 on the red graph in here, I'm going to use the highlighter to show you. So in here or over here, those values are going to be shooting really far away from the x-axis, and then these values down here, these larger numbers are going to get smaller. So the graph is going to end up looking like this. And all of the values over here and in here were already negative. So they're going to stay negative when you do the reciprocal. So you're going to have nothing cross over the x-axis. It's a really bad version of the graph. My pen is slipping. But again, I'm hoping that you're getting the idea. Okay, so then this one here, you're supposed to try on your own. So what I'd like you to do is pause for a moment, try it on your own, and then come back and look. And I am going to be also just putting the work on here. So if you want to follow along as I'm doing that, you can, but I'm not going to talk. I'm just going to do the work and show you what I'm thinking. Okay, so the domain restrictions turn out to be negative infinity to -3 and then 3 to infinity. All right, hope that makes sense. Again, write down your questions. All right, last but not least on this long-ish video, unfortunately, is how to do some transformations on unknown or random graphs. Okay, so sometimes we call these random transformations. So you're literally doing compositions on a graph that you don't have any information about, like you don't know what the function is. You absolutely do not want to come up with the functions. You want to figure this out just with the points that are here. So what I would recommend is find some of the defining points on the graph. So this is -2, 3. This is 0, -2, 2, -2, and 2, 3, 4, 5, 1. Okay, I'm going to take those 4 points and I'm going to perform this transformation. So, excuse me, this is actually the hardest of all the transformations on this last part. Okay, so what this is telling you to do is to take the x value and put it in to the absolute value. So if I were to think of doing this first point, let's just do 5, 1, okay? So it's f of the absolute value of 5. Well, that's the same as f of 5. And according to our graph, f of 5 equals 1, because this is f of x over here. So I'm graphing 5, 1. Okay, well, the same thing is going to happen with the point 2, negative 2. You're doing f of the absolute value of 2, which is the same as f of 2, which is equal to negative 2. So that point doesn't change. Same thing with the 0. So f of the absolute value of 0 is the same as f of 0, which equals negative 2. Okay, so these 3 points did not move at all. The temptation when people see this absolute value on the x is to take all of the points over here and just reflect them, thinking of it as a reflection, and take all this stuff and move it over here. And that is not what's going to happen. So we're going to talk through then what actually is happening. Okay, so we're going to move on and just look at the point f of negative 2. Okay, so f of, put negative 2 in for x. Well, f of the absolute value of negative 2 is the same as f of positive 2. And again, according to our graph, f of 2 is equal to negative 2. So what this means is we now have to throw on our graph the point negative 2, negative 2. Okay, so feels like it's copying itself over. But here's the trick. Okay, well, if I go to do f of, let's say, absolute value of negative 4, it seems like you should just go, well, that's f of 4, and look over at what f of 4 is and graph it. However, there are no negative things over here past negative 2. The domain of the original function was started at negative 2. So I have no more points past negative 2 that I can do in the problem. So literally, this is the end of my graph right here. This is it. Because I have no more points. My domain of my function stops right here. Okay, I can't figure any more out. So that's it. That is that first problem. Okay, moving on to B. These get a little bit easier. So when I am doing something with the absolute value on the y, so let me write these points down again. This is saying take whatever the y values are that you get when you substitute the x value in and make them positive. So f, it's the absolute value of, let's say, f of 2 of x, or sorry, the absolute value of f of 2. Well, you're finding f of 2. F of 2 off of your graph is equal to negative 2. But now I want the absolute value, so it's positive 2. So all of my negative values become positive, and all of my positive values stay the same. So 2, negative 2 becomes 2, positive 2, which means 0, negative 2 becomes 0, positive 2. So my graph is taking on this shape like this. I'm approximately at 0, right at negative 1. We're going to go with it. And then negative 2, 3 stays at negative 2, 3. Okay, that's it. And we need that graph. I'm going to snip the whole thing because I can. To then do this next transformation here. So this one, we're taking, oops. So we're going to take and shift the graph to the left one, and then take the absolute value. We'll get rid of this. We'll do it all together. And then shift it down 2. So let me write down these points one more time. Negative 2, 3. 0, negative 2, 2, negative 2, 5, 1. Okay, so this x plus 1 tells you to shift everything to the left 1. I'm actually going to do all this on the grid. So we're going to go to the left 1. So negative 3, 3, negative 1, negative 2. Here. So here is the shifted to the left. Well, now I want to make everything positive now that I've shifted it to the left. So this point here is negative 3, 3. It doesn't change. This point here is negative 1, negative 2. It is now going to become positive 1. Sorry, negative 1, positive 2. This point stays at 0. And then now this point comes up here. This point stays at 0. Okay, and here we are. And then you want to take that whole thing and shift it down too. So the green graph is my final graph. Okay. I hope all of that makes sense. I hope that if you have any questions, you will put them in the question document or email your teacher. Have a great day.